Hello and welcome back for another VMK in the game development series. In this bonus video, which is only available on the DVD, I'll show you how to modify our existing GUI class so that you can manipulate the GUI controls dynamically while you're running the game. This will make things a lot easier to organize your GUI controls visually. Using this extra functionality, you'll be able to lay out all of your controls and then test them out whether you like them or not, and then if you do like them, then you can save them into a file which you can then use later on whenever you're loading up your GUI controls. So to start, let me demonstrate how this is going to work. Here we have our standard GUI. I'm going to go into the options menu where I have a lot more controls to play around with. What we're going to do is we're going to add a new control here. By typing in GUI, we're going to enable the GUI controls. So now you can see here it says GUI move enabled, and with this being enabled now, I can go in here and highlight over top of any of these controls, click and drag, and you notice that I can pick these items up and move them anywhere I like. So I can move them around, even these radio buttons, I can grab the whole group and then I can move the labels around as well. Any of the controls basically, I have full control over them using the mouse. The other thing I have here is, notice when the console window is open, as I highlight over top of certain objects, it tells me which GUI control number I'm currently selecting. So this one here is number 17, this one down here is 26, and so on. If you create a listing of all your controls, you'll know that number 25 is this slider here, and number 14 would be the image slider here. So you can keep track of things like that as well. Once you're done moving things around however you like, you can just type GUI again a second time, and now you've disabled the GUI move. With it being disabled, you now have full control over using these GUIs just as you would normally. And notice that all the functionality is still in place, even though I've moved things around. So this is what I'm going to show you how to create in this VMK. Okay, to start things off, we're going to need to modify our game engine's user settings class. This class is going to be responsible for keeping track of which control is currently activated as well as which control we're moving. So as we click and drag things, we can keep track of the position of this control as well as the control ID so that we know what we're working with. We also need another variable to keep track of whether this GUI controlling is actually turned on or off. So we're going to have a Boolean variable to keep track of that. So here's these three new variables we're going to need. We have vertex 2 GUI position. This is to keep track of how far we've moved the specific control that we're controlling. We have a flag here to indicate whether we have GUI movement turned on or off. And then we also have an integer here that tells us which GUI ID number that we are currently controlling. So we need to record that. We're going to initialize these variables inside of the constructor. So going in here right at the very bottom of this section here, let's add the following. We're going to disable the GUI move, so it's going to be set to false. And whenever we're not controlling any GUIs, we're going to set the GUI control ID number equal to -1. Anytime we are controlling something, this number here will be positive. So let's save that. Now, to enable or disable the GUI controls, we're going to be using the parser that we've developed for our scene class. Right in here, console parse. And just like any other of the commands that we've added in here, we can type in to do a string comparison with the actual command that the user is going to be typing in. So at the very bottom here, let's add the following. We're going to be looking for the keyword GUI, and anytime that the user types this in, what we're going to do is we're going to toggle the current state. If it's on, we're going to turn it off. If it's off, we're going to turn it on. We're going to set the console param error to be false, and we're going to create a function called GUI movable toggle. So what this is going to do is just toggle that Boolean variable we just finished creating. Then we're going to go and check to see if the current state of the GUI control movement is turned on. And we do that by using this function here, is GUI movable. If this guy returns true, then we're going to display to the screen GUI move enabled. If this guy returns false, then we're going to display to the screen GUI move disabled. And then we also, if we are disabling it, we should set the GUI controller equal to -1 because that's the default whenever there is no control being controlled. So let's save this and start filling in these functions that we're now going to be using. Let's go back inside of user settings, and we're going to go and let's just add them here at the very bottom. Okay, to start off, we have is GUI movable. This function is just going to return a Boolean variable, and the variable we're returning is this variable bGUIMove, which is going to keep track of whether we have the GUI enabled or disabled. GUI movable toggle is responsible for toggling that variable, which we're going to be returning up here. So whatever value is currently set here, we're going to just negate it and then save it back to ourselves. We also have a set GUI controlling as well as a get GUI controlling, and this guy is responsible for keeping track of which GUI ID number we are currently controlling. So whatever we pass in here, we're just going to save it into our own member variable, and then using the get GUI controller, we can retrieve that ID number. Okay, now we have to start modifying our existing structure for our GUIs. We will start off by going into here, GUI check hotspots. Right now, this function is responsible for keeping track of all the controls so that any time that the user highlights or clicks over something, then we do the appropriate action down here. But now we also have to split this up a little bit so that if we are in GUI edit mode, then we can't directly control the specific GUI. We don't want it to activate whenever you're pressing on it. Instead, we want it to behave slightly differently so that we can move it around with a click and a drag. So to do that, what I'm going to need to do is change the return value from this GUI check hotspot to be an integer. And by changing that, you also need to go inside of the scene.h file and change it in here. By making this change, will allow us to return the current GUI that we are controlling. And if we're not controlling one, then by default, we're going to be returning -1. Okay, so at the top here, we're going to add a new variable called iControlling, and by default, it's going to be set to -1. And then down inside of this for loop, we're going to make the following modifications. First thing is inside of check hotspot. Currently, we're taking the X and the Y value of the mouse as well as the mouse button and applying it to the current control inside of this loop. However, we know if GUI edit mode is enabled, we don't want to activate these controls as if they're regular controls. So the only way we can activate controls is if the mouse button is pressed down, which is controlled by this variable here. So we can replace this with the following, and then what we're going to do here is check to see if is GUI movable turned on. If it is, then we'll always set this last variable inside of this function call equal to false, which means the mouse button is not activated. If GUI edit mode is not enabled, then we're going to use the regular setting here for the GUI left mouse button. If the GUI movable is turned on, this is false. If it's off, then it's dependent on whether the mouse button is pressed or not. Alright, moving on down here into this if statement. We now need to make a distinction between whether we're in GUI edit mode or not. So this first if statement here is going to say, well, we're going to go into this first if statement if we're not inside GUI edit mode. So we're going to take all of our existing code in here and we'll just move it over so that it's all inside of the if statement, like so. And we'll close the bracket here. Now, if we are in GUI edit mode, then we're going to check to see the state of the left mouse button. If it is pressed, that means the user is clicking and possibly dragging. Then we want to record which current control is being activated. So we take the current control and save it inside of iControlling, which is the value that we're going to be returning out of this function, but we also want to save it inside of puser settings by calling the set GUI controlling. And this guy is important because later on we need to use this value here to distinguish how far we're going to move our control as we're sliding it across the screen. The other thing we're going to do here is add a variable to our scene class called m_ssetGUIInfo, and this guy is going to keep track of which control is currently being controlled. So we're going to show GUI space and then the ID number of the control that we're controlling, which is IC, and then the X and Y coordinate of this current control. So we're going to pull that out of the containers current controls get position X as well as get position Y. So it's a little bit of a compounded function here, but basically what we're doing is we're getting the control ID number and the position of the control which we're controlling. And then we're going to break out. Now we're breaking out of our for loop, which is going through all the different controls, which means that you can only control one GUI element at a time. You can't grab more than one item as you're using this GUI edit mode, which should be fine. We also need to change this return value here, so now it's going to be returning the iControlling value because GUI check hotspots is now responsible for telling us which control is being controlled. Alright, let's save all of that. Before I forget, let's go into our scene header file and declare this variable here, which is going to be containing all of the data about the GUI control that we're controlling. So back inside here, scrolling down to, where's our GUI section? Here it is. Add the following. We have m_ssetGUI_info, and I'm going to allocate 128 characters long for it. And inside of the constructor of our scene, we're going to initialize this variable. We're going to leave them blank initially. Let's just put it up here with this other GUI control item. And now going back inside of the GUI check hotspots, right at the very top, anytime we call this GUI check hotspots function, we also want to reset the string that's being saved inside of this variable. We don't want anything in here because if we go through and decide not to control something, we don't want to display a string to the console window. Instead, we want to leave it blank. But if we are controlling something, then it's going to get overwritten down here with this command, and it's going to update to tell us what is the current position of the control and what is the control ID number. To make this string actually appear inside of the console window, we need to go inside of console render right here, and let's see here at the very bottom, let's make this modification here. Okay, according to this, we have line 5 is the current game time. Well, let's do the following. If we're in the play state, we're going to display the game time just as we always were. However, if we are not in the play state, which means we're probably in some sort of menu, then in here, if we're in GUI edit mode, we're going to go in and display the current string that's saved inside of this ssetGUIInfo. So that should display our strings to the screen. Let's save this guy. Now let's compile our code to see if we've made any mistakes, and then we'll try to run it. Oh, there's something wrong in here. Missing colon. Oh, vertex 2 is probably not included at the top here. No. Add that and try to recompile the user settings. He's good. Let's try building. Okay, let's give it a run. Inside of here, we're going to bring down the options and type in GUI. Okay, GUI move is now enabled, so if we highlight over top of something, you notice that at the top here, this is GUI control number 2, and his current position is 246 in the X direction and 371 in the Y direction. This control here is GUI number 1, and it's 304 by 293, and this one is GUI 0, which is 326 by 175. So we got control over them, and if we click on them, notice that they're not becoming activated because we don't want them to become activated, but we can't currently click and drag them around because we haven't incorporated that functionality just yet. Now let's turn the GUI control off and hit the options button, and it goes into our options menu just the way it should. And in here, let's try it out as well. If we go and click, we can't drag things around, but in here we can see that it seems to be getting the GUI control numbers correctly, and the positions of all of our controls are visible as well. Alright, so that seems to be working. Now all that's left to do is incorporate the functionality to be able to move our GUIs by clicking and dragging on them. To start the whole movement process, you need to know where the mouse is currently positioned whenever the mouse button is pressed. So to figure that out, we can go inside of our game OpenGL class, and inside of our message handler, we'll keep track of any time the mouse button is pressed. Let's just scroll down here to find that event. Here it is here. Left mouse button down. We're going to replace this function call right in here with the following. If the GUI check hotspots returns something that's not equal to -1, then we know that we are over top of a control that we may be about to move. So we need to check to see if the GUI movable state is turned on, and if it is, we need to set the current GUI position. What this is going to do is record the current position of the mouse inside of our variable back in here. Let me show you that variable. We're going to save it right inside of this variable here, so that when we do move our mouse, we'll know exactly how far we've moved from our starting position. Then, whenever we go and render our GUI that we're controlling, we're going to offset it by the distance that this variable here is recording for us. That's the way that this entire structure is going to be working. The other thing we need to modify while we're in here is down here under the left button up. If we go in and set the mouse button state to be false and do the release mouse call, we also now need to add the following. Set GUI controlling equal to -1. We set it to -1 anytime that our GUIs are not being controlled. So it's important that you reset this value up here to be -1 whenever we release the mouse button. So here I just said, if in GUI move mode, stop controlling from moving our control. Alright, so now we need to go into our user settings and implement some functions. Here's our first one, set GUI position, and this is used to store the current mouse position inside of this variable so that we can use it later on. And when I say use it later on, this is the function we're going to be calling. Get GUI position change. He's responsible for returning to us the current offset of the mouse. So we're going to get the mouse position at this current time and subtract from it our original position of the mouse, which was stored up here. This will give us a delta change of the mouse, and we're going to return that out of this function, which we'll then use to offset the GUI position. That's under our control. So let's save this, and let's just compile user settings. Oh, we must have forgotten something here. This just should be v2 temp. Alright. Now the only thing left to do is move our GUI control that we are controlling before we go and render it to the screen. To do that, we'll need to go back inside of our scene class, inside of GUI render, in here. At the top here we have if time change is equal to 0, so we initialize all of our GUI controls. And then down here we had our for loop, which goes through all of our controls and renders them to the screen. Well, we need to modify this now, because if we are about to render the one that we are controlling, or we want to update its position before we render it. So right above here, we're going to add the following. If our control, our current control, is equal to the get GUI controlling value, then we know that this currently selected GUI control is the one that we are moving. So we need to go in and get the current controls type and check to see if it's a radio or if it's something else. We need to distinguish between these two different states because a radio control is updated slightly differently than a regular control, because you'll remember that a radio control has a grouping of classes, and because of that grouping we need to change its root position rather than its actual position, because its position is the position of its very first control in the grouping, but the root of its position is used to move the entire grouping. So let's take a look at this here. First thing we do is we take the current control's value, cast it as a GUI radio pointer, and save it inside of pradio. And pradio should be defined up above, up here outside of the for loop. Alright, so here we go, we have pradio. Now, what we're going to do is we're going to get the root position of our radio button and save it inside of this vertex 2. We're going to need two more variables to keep track of this x and y position. So again, up here we're just going to add two floating point numbers. And here we're just saving the x and the y coordinates of this vertex 2 root position. We're using the get GUI position change value, which is the total value that the mouse has moved since the last time it was rendered. And we're saving that inside of this vector2 change variable. And again, we need to define this guy up above. And he's going to be just a vertex 2. So this is going to give us how far our mouse has moved since the last time you rendered to the screen. Then what we can do is we can call the set root position on the radio control, and we're going to pass into it how much it's changed in the x direction plus the fx value, plus how much it's changed in the y direction plus the fy value. This is effectively going to slide our control however far our mouse has moved. And then we go and call update so that we also update the current position of the mouse so that when we go and render this next time, this GUI control, our new mouse position has been recorded for use appropriately. If we don't do this, then you'll notice that the GUI control we're controlling begins to slide faster and faster every time we move the mouse. Now, if we're not using a radio button, then we're going to go inside of this else statement where we do something very similar. We get the x and the y position of the current control. We save it here inside fxfy. We get change in position of the GUI based on how far the mouse has moved. Save that into v2 change. And then we need to update the GUI's position by calling set position x and set position y by passing in fx plus the change and then fy plus the change as well. And then at the end we just update the current mouse position inside of the variable that keeps track of where the mouse is. Now if we save this, we should, I think, be able to slide our controls around on the screen. Let's give this a try. Type in GUI. Now if I click and drag, notice that the options control is moving around for me. I can take these and position them anywhere I like. If I click on these, they don't activate because we've disabled that functionality. We can only click and drag to move them around on the screen. To make them work again, you need to type in GUI to disable the GUI move command, and then now from here we can go and hit the options button and you're back to regular functioning mode. So there we go. That's how you create a dynamic GUI manipulation system inside of our game engine. Now you can take this a little step further if you like and imagine that you want to save these variable values every time you finish editing your GUI screens. Because right now nothing's getting saved. Like if we go and exit our program and rerun it, notice that everything is back to its default value because the constructor of our scene initializes all these to certain state which has been hard-coded. But what you can do is you can go in and modify this functionality so that after you move everything, it has the new position coordinates here. You can see in the top left-hand corner. This is 140 by 244. You can take that value and save it to a file somewhere. Then, anytime that your program starts up, what you should do is load in the values from that file so that when you initialize your controls, they'll be positioned at wherever the user last left them. Very similar to the way that we initialize all of these states anytime that the user starts up the program. Laying out any GUI screens is kind of difficult if you're trying to do it all with numbers. But with this new graphical user interface, you can just quickly drag and drop everything around on the screen so that you can position things wherever you want them. And if you don't like the way they look, then you can go and reposition them however you like. So that's the way that I ended up creating this layout for all these controls, but I didn't show you that initially because this was an extra step that took a little bit of understanding to sort of visualize how everything is getting controlled inside of the GUI controller. Oh yes, when you are defining all of your GUI controls, make sure that you give them unique ID numbers. If you don't give them unique ID numbers, you'll notice that if you go and grab one control and start sliding it around, you may notice that the control you grabbed is not the one that's moving on the screen. This will be because you have duplicate names and the code doesn't realize which control is the one that you're grabbing. Remember, we had a for loop that goes through, tries to find the first instance of the controller ID number that it finds that you've grabbed. If there's multiple ID numbers that are the same, then it's only going to always grab the first one. And the other thing is if you start stacking your control something like this, it may become difficult to grab the specific control you want. And I noticed that was especially true with these sliders and these labels. The slider here is positioned very close to the labels, and sometimes it's difficult to grab the labels without grabbing the slider. So to fix that, what I did is position the slider far away, take these labels, position them where I think they should go, and then slide the slider down to make it sit nicely with these labels. If you can't grab these labels because you keep grabbing the slider, just move the slider out of the way, move the label, and then put the slider back to where it's supposed to be.